Hi, this is Remembering the Past, the show where we talk about people who died recently who've had a profound effect on our history, our society, or our culture. And in our ongoing series on Nobel Prize winners, tonight we're going to cover Dr. Richard Heck, who died recently at the age of 84. Dr. Heck shared the 2010 Nobel Prize in Chemistry with two Japanese chemists for their work on integrating organic and inorganic chemistry. Rather than mangle the name of the two Japanese chemists as I've done in the past, I'm going to start by playing the 2010 announcement in Stockholm of the Nobel Prize in Chemistry.
Welcome to this press conference where we will present this year's Nobel Laureates in Chemistry. This year's prize awards great art in a test tube. The Royal Swedish Academy of Sciences has decided to award the 2010 Nobel Prize in Chemistry jointly to Professor Richard Heck at the University of Delaware in New York, USA, Professor Ei-ishi Nigeshi at Purdue University in West Lafayette, Indiana, USA, and Professor Akira Suzuki at Hokkaido University in Sapporo, Japan. And the Academy citation runs for palladium-catalyzed cross-couplings in organic synthesis.
Not so sure I would have done worse with those Japanese names than a guy who says USA for USA. What are palladium cross-catalyzed couplings in organic synthesis? Well, organic compounds, those with a carbon structure, especially when they're attached to a halide, something that has an ene or an ide in it, bromine, chlorine, fluorine, iodide, do not combine well with other organic compounds. Dr. Heck was the first to realize that palladium, an expensive metal, could be used as a catalyst. That is, an agent that would facilitate and speed up the reaction and allow two organic compounds to bind together and create a more complex molecule. This became known as the Heck reaction. Here's a brief explanation of it.
Developed a chemical reaction to link carbon atoms using the silvery metal palladium as a catalyst, with an activator such as iodine. Palladium works as a point of rendezvous to bond the carbon atoms without being affected itself, a little like a priest at a marriage. Usually, carbon atoms are difficult to unite, the process requiring a great deal of energy. The work of the Laureates has enabled carbon atoms to be joined more easily and efficiently, with less waste.
We'll talk more about Heck reactions in a little while. I just wanted to give you a little of Dr. Heck's background. He's actually atypical for a Nobel Prize winner. He was born in Massachusetts, but his family moved to California when he was a little boy. His father tried to make it as a farmer out there, which is what interested him in chemistry. He got his undergraduate and then his graduate degree at UCLA. Then he did a year of postdoc work in Switzerland with Vladimir Prelog, who won the 1975 Nobel Prize in Chemistry. And then when he came back to the United States, he didn't go back to academia. The interesting thing is he went into industry. That's unusual for Nobel laureates in the middle of their careers. Usually they stay in academia. He went to work at the research center of the Hercules Powder Company in Wilmington, Delaware. Hercules Powder is now part of Ashland Incorporated. And he stayed there for over a decade. I have a feeling he was doing some heavy-duty research there, and it says his position was terminated in 1971. A lot of times that means he wasn't being productive for the company and turning out the stuff they wanted. But he was obviously doing some good work. And one of his supervisors there encouraged him to work more with transition metals, and that paved the way for him when he left Hercules Powder to go to the University of Delaware. He won his Nobel Prize for the work he did at the university, and they're understandably proud of him there. He's only one of two Nobel Prize winners from the University of Delaware. The other was Daniel Nathans, who was a biochemist there, and he won the 1978 prize for physiology or medicine. Well, as I said, the University of Delaware is quite proud of Dr. Heck, and from one of their websites, they prepared a little piece on him and his research.
The Nobel Prize. Since 1901, it's been awarded to those who have changed the world and the way we see it. This is the story of a humble chemist with roots in Delaware who did just that.
I'm Mary Watson, on the beautiful campus of the University of Delaware, where Richard Heck did his most groundbreaking research. He won the Nobel Prize in Chemistry in 2010, but his interest in chemistry started much earlier.
When I was a teenager, my parents purchased a new home in the suburbs of Los Angeles, sort of on a desert-like lot. My father and I got involved in planting the yard. I got to worrying about what chemicals were involved in fertilizers, and I then began reading about it, so that got me into chemistry. I took the chemistry courses in high school because this was just before I went into high school that I got interested in it.
After college, Heck earned his PhD at UCLA, working with Professor Saul Winstein.
Well, he was a good teacher. He really knew chemistry, I think, and he really inspired me because of his knowledge, and he seemed to have an answer for every question you had.
After postdoctoral work in Switzerland and California, Heck moved to Delaware in 1957 to work first at the Hercules Chemical Company and then at the University of Delaware.
It was here in Delaware that Heck made his revolutionary discoveries, not for fame, glory, or money, but because he saw an opportunity to do something useful for society.
Have windows. Well, I was always looking for new chemistry, and I think that was my main goal. I used to try to make life simpler, I guess.
And his boss said to him at Hercules, said, why don't you do something with metals, transition metals to be exact. So if you study transition metals at that time, you're way ahead of the field. That's what he did.
So what was this discovery that changed the world?
Well, it's simply a palladium-catalyzed addition of organic halides to double bonds.
What does that mean? Well, it's kind of like making a peanut butter sandwich. Without a knife, it's pretty hard to get the peanut butter onto the bread.
The palladium catalyst acts like the knife to create a new molecule. First, palladium takes this carbon atom out of the peanut butter jar, and it moves it toward the bread, or the double bond. By putting these two carbon atoms close to each other, palladium gets them to react to form the sandwich, or the new molecule. This simple idea, the use of a palladium catalyst to cross-couple otherwise unreacted molecules, completely revolutionized the molecules we're able to make.
If Professor Heck hadn't discovered what is known as the Heck reaction, the pharmaceutical industry would be a much different place. The tools that we use to catalyze reactions and synthesize new molecules are really reliant on many of the principles that Heck first established.
The Heck reaction has had tremendous impact on our daily lives. It's used to make medicines for pain and asthma, sunscreen, herbicides, and performance materials for electronics. But Heck's contribution goes further than the Heck reaction. His strategy of using a palladium catalyst has inspired many other scientists.
He has laid the groundwork for many people in many different areas to tremendously expand the kinds of molecules, molecular structures, and molecular matter that they can access.
I would like to offer my sincerest congratulations to one of my heroes, Professor Heck.
Heck's co-laureates, Professor Ei-ishi Nigeshi and Professor Akira Suzuki, developed other reactions that also use palladium catalysts. Although their reactions use different starting materials, they still rely on a palladium catalyst to bring carbon atoms together. Since Heck's discovery, scientists have figured out how to use palladium catalysts to build all sorts of bonds, like carbon-carbon, carbon-nitrogen, carbon-oxygen, and carbon-fluorine. Even with all these incredible applications, the full impact of Heck's groundbreaking discoveries has still not been fully realized. His research continues to inspire scientists at the forefront of chemistry.
Professor Heck was one of the first people in the world, really, to study the mechanisms of organometallic reactions. And so what that means is basically he was one of the first people in the world to really understand how the molecules come together to do what they do in these reactions. And so for me, that was really inspiring, not only because I'm particularly interested in studying using palladium to make new bonds, make new chemical bonds, but also because I'm really interested in being able to understand how the reactions work so that we can design ways to make them work even better.
Many challenges confronting society today may ultimately be solved by new scientific discoveries. Heck's story shows how a humble scientist and fundamental discoveries in chemistry can have remarkable impact. Heck did indeed change the world.
Well, in describing how Heck changed the world, I'm going to quote from the NobelPrize.org website. Undergraduate students learn about the Heck reaction and perform experiments based on it in the laboratory. Process chemists perform palladium-catalyzed reactions in the large-scale manufacture of fine chemicals, fragrances, pesticides, and pharmaceuticals. Of all the chemistry developed by Heck, maybe the greatest social impact has been from the palladium-mediated coupling between an alkyne and an aryl halide. This is a reaction that is used for fluorescence labeling of DNA bases, which has contributed to the automation of DNA sequencing and sequencing of the genome. Heck's work has motivated thousands of researchers to explore the unique possibilities of palladium catalysis in their own work. Richard Heck laid the foundation for virtually all the metal-catalyzed coupling reactions that are an essential component of modern organic synthesis. That's pretty good for a guy who was actually pretty quiet, pretty shy. He never liked to beat his own drum. Here's what he said about his work.
I haven't made a cent out of it, but then I did something that turned out to be useful, yes, indeed.
Like I say, Richard Heck was a man of understatement. Well, I'm going to close on that note. I want to thank my producer and IT genius, Sid Tepps. Let me say that it's not that easy finding a closing song that has palladium in the lyrics, but I'm nothing if not resourceful. And of course, the song that does have palladium in it is the 1959 song The Elements by that Harvard genius Tom Lehrer, sung to the tune of the Major General song, a parody of Gilbert and Sullivan. I can't play the whole thing because it's more than 30 seconds, but I'll start off with Palladium in honor of Dr. Richard Heck, our 2010 Nobel Prize winner in chemistry.
Palladium, promethium, potassium, polonium, and tantalum, technetium, titanium, tellurium, and cadmium, and calcium, and chromium, and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, kryptonium, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.